Recording. And go. All right. So, welcome to today's Prodigy class. And today we are going to be doing our lesson 4 for our FPS game lesson. So, today what we're going to work on is enemy pathing, enemy AI, right? And this is often considered kind of a daunting task for some people, but I'm going to make us a simple one today and hopefully kind of broaden our idea of what an enemy AI is. Traditionally, when we speak of AI, we're talking of artificial intelligence. And we categorize intelligence with our own ideas of what being smart is, right? You at home, you listening or here in class today, are intelligent. This enemy, although we are making an AI, is not going to be anywhere near as smart as you. You are just making the illusion of being intelligent. In truth, game AIs aren't that smart. They will do decision making, but you're going to need to tell them how to do their decision making. So, to start off class today, and if I've spoke to you before we did recordings, and you have your parts, then you have your parts. But to start off class today, we're going to make an enemy. To make our enemy, let's make a quick cube. And again, if you already have this, don't worry about it. And we'll name that cube enemy. Now, me personally, I'm going to resize this cube for a second by hitting the R key to distinguish it from the other cubes here that are our placeholders. And I'm going to move it away from the player a little bit because we're going to be doing some fancy code with this. Alright, we need to make sure our cube has a rigid body so that it is affected by gravity, and then we can begin really working on this. So, to begin getting this cube to attack this player, it's going to be similar to our simple ball game. Let's go to our assets in our projects folder here. And we're going to go to our scripts folder. Now, if you don't have a scripts folder, what you're going to do inside your assets here, you're going to right click, you're going to go all the way up to create, and you're going to go to folder. And then you're going to make that folder, you're going to name it scripts. In truth, it can be named whatever you want. This is just to make sure that we are staying organized and neat. That is a habit that we are going to want to keep. It's going to make our lives easier. Anyway, now that you have your scripts in here, we're going to click on that folder and we're going to open it up. Now you'll see I have some already here. For this lesson, you don't need to worry about these. What we're going to do is we're going to make a new one. So, in here, we're going to go to the right and we're going to right click. And we're going to go to create. We're going to go to right underneath a folder. You'll see C# script. Alright, so I'll do that again. I'm going to right click, go to create, C# script. You're going to click that and then we're going to name it. We're going to name this enemy AI. And then hit enter. Right? And that's going to lock in the name. Once you have the name made, even if you misspelled something, don't change it. You're better off deleting it and making a new one. Because that locks in certain parts in your code that is going to cause different errors. And it's better off just to avoid complications like that. Alright, so now we are going to begin with a program called Visual Studios. So what we're going to do is we're going to click Enemy AI twice, and it's going to start booting up something called Visual Studios. Right. Now, if you have an error booting this up, that's fine. What I would encourage you to do for the rest of the class is just pay attention, try to understand what we're doing, and then I'll hang out at the end of class and help you fix that error. But if you don't have an error and it's pulled up your screen just like this, then we're good. We can keep going. Awesome. So, how are we going to make our enemy recognize that our player exists for one, turn to our player, and then move towards them? Well, we're going to do this with 3 simple steps. Number 1, we're going to use a overlap sphere command, right? Now, when I say overlap sphere, what do I mean? Well, Unity has in its physics engine a pre-built sphere tool that will tell you any object that overlaps within a radius of a sphere. And you can tell it where to pop up, where to start, and we're going to have it pop up right around the player. The next bit is determining whether or not it is the player. So once we determine it's the player, with a simple is your tag player or is it not player, then we are going to use the lookat command. And the lookat command is also a pre-built thing within the vector 3s. That vector 3 just is pretty much the location, it's your transform. And lookat will position our cube, our enemy, to have its front face towards whatever we tell it to. And then lastly, what we're going to do is we're going to use something called translate, which is part of the transform, same as the lookat, and that is going to move our enemy closer to the player. We're going to have it only move close to the player if it is picked up within the sphere, so that our enemies will have a range of hostility. All right. Now there's going to be some inherent errors that come out of this code, but we're not going to focus on them for right now. Right now we just want our enemy to look at our player and then move towards them. We're not going to focus on any damage. We're not going to focus on them taking hits. We're just going to keep it simple for today. We want to get back into the swing of things. We had 4 days off. So, to start off, what we're going to do is we want to get the rigid body of our enemy. This is going to help us later in making sure our code is shorter. And shorter code means it's easier to pay attention to, makes it easier to read. So, in here, inside of our public class, right, you'll see public class enemy AI model behavior. We're going to go to our line 6, right outside of the curly bracket. We're going to hit enter. And what that's going to do is it's going to add a new line. And in here, we're going to type in private. Notice that Unity wants to finish what I'm typing. Let it RB. Or sorry, we need to do private rigid body, capital RIG, and then rigid body. And we're going to name that RB. It should look exactly like that. Then, other things we're going to need. We're going to write public float. Now, when I write float, I'm talking about any decimal number, right? And we're going to do speed. So we have the float, the speed, just a moment. All right, I'm sorry, I was muted there for a moment. Anyway, going back to what we were working on, we're adding in the rigid body and a float, which is the speed, and float stands for anything with a decimal place. So anything that's like 1.5, 1.2, 0.2, 121, point whatever. As long as you have a decimal place, it is a float. And we traditionally use this for things like time or speed. Now that we have our speed, we're going to want really one more variable to this, and that's going to be our range. So we'll do another public variable, and we'll also make this a float, and we'll just name it range. Right? Range is going to dictate how far away our enemy will look. Speed is going to dictate how fast they will move, and rigid body is just going to help us in our code. So now, in order to get our rigid body really working, we're going to move into our start here. And in here, we're going to type in RB equals, just a moment, I think I got a pling for a question. Check that. I did. Yes, you can leave, Derek. You're good. All right. Sorry about that. Anyway, going back into our code here, we're going to have RB equals game object with a lowercase g dot get component rigid body. And I'm going to start picking up the pace here a little bit because Mahedra, I know you're good. I guess Derek had something that popped up. That's totally fine. So RB game object get component rigid body. That sets rigid body to what we need it to be. Now we're going to make a new function. And we're going to make this function called look or looker. So void look. And now there's a few things we can do, but what we're going to do is we're going to do this very simply. We're going to make a list of game objects that uses physics dot overlap to work. So when we do this, if you go to the classroom and you look at lesson 4, you'll see that we have overlap right here. So we can click on it to make sure we are using it correctly. So as you can see, they make a list of colliders that takes in a center location and a radius, and then through that list, it goes through it and adds damage, right? So we know we need a list of colliders. I'm actually just going to take their script here. Like, I'm just going to take this because this is in UD's handbook. This isn't plagiarism by any means. This isn't taking anything. That's the way you do it. Period, end of story. And I'm going to just drag that over to our code here. You can choose to copy it from me. You can choose to copy it from there. That's fine. But now we have our list of colliders. We're going to call it hit colliders. It's a good name. Equals physics.overlap sphere. Then we have the center and the radius, right? Well, we know we want the center to be our position, so we're going to change that to transform.position. Then we know we want the radius to be our range. All right. Now, once we have this here, we're going to do another new thing. And we're going to use a loop called a for each loop. It's very similar to a for loop, right? But I find these very, very useful when programming a game. It lets you navigate lists so nicely. So the way we do this is we write for each, and we'll do collider. Oop, my bad. For each collider. And then we got to name those colliders. So we're going to do C, right, as the name, in hit colliders. So now what this is going to do is for each collider in hit colliders, it's going to go through this loop. If hit colliders is nothing, it won't go through it at all. And then we're going to add an if statement inside here. If C dot game object dot tag equals player, then we're going to want it to do some code. Now, there's a whole bunch of things we can do, right? But I think the best thing that we can have it do is have it return our player object. Now, how do we get it to return our player object? It's super simple, super duper simple, but we're going to have to do a little bit of legwork up here. So you see where we have void look? If you go between void and look, we're going to write in game object. That's not right. We're going to get rid of void as well. Once we get rid of void, game object, there we go. I spelled it wrong, my bad. So now that we have game object look here, what is this going to do? Well, what game object look is going to do is it's going to return a game object. The way we do that is we go back into our codes, we go back into my line 30, and we're going to do return C dot game object. And then to make sure that everything works here, we need a return that is not conditional. So we're gonna do another one outside of our for each loop. So below this bracket here, we're gonna write return null. And now null means nothing. It means not even zero. It means there's not. We don't even know what zero is. It's just absolutely nothing. Okay, I'm gonna give us a minute to really digest that and put that in, because next we're gonna write our movement script. All right, cool. So now that we have this, we can call it, and every time we call it, it's gonna check around the sphere and go through the list of objects. And if the object is labeled player, it's gonna return that object. In fact, I want to add another line of code to this, and I'm terribly sorry for having that pause and then doing this, but if we look at my line 30, right underneath the return code, we're going to do something called break. And what that does is it escapes whatever loop our code is in. All right. So what break does is it will escape the for loop here, and just exit the code. In fact, I am seeing is that going to be a problem? No, that won't be a problem. Okay, so we return our game object, everything's good. Now we're going to make our move script. So we're going to do void move. And we're not going to do whatever this thing has just made. Do void move. Again, I don't want this. So this is the one problem with Unity, in that it really wants to help you. But if you really don't want its help, it's hard to tell it no. Alright, so we avoid move. Now, what are we going to do for move? Well, we're going to check if look is returning null, and if it is not, then we're going to move towards that object. So, move is as simple as writing if look does not equal null, then we're going to do transform dot position equals transform capital T dot translate and now wait. So I messed up. I'm terribly sorry. We're going to do transform dot rotation equals transform, or can we do just this? Yeah. So I'm terribly sorry for jumping around there for a hot second. That's my bad. We're going to do transform dot look at, and look at is our function. And then we're going to do a target and then our world up. So to do this, we're going to do look, and look is going to return our game object. Dot transform dot position, and then we're going to do vector3 dot up. All right, so take a look there. That's what we need. The other bit we're going to add in here is right underneath. We're going to go transform dot translate, and translate takes a bit of code. We've used it before. We've used it in our move controller, where we move along our horizontal axis here to move forward. Yeah. So what we're going to want to do is simply do 0f, 0f, and then we want some sort of forward speed. So we're going to do vector3 dot forward times our speed. And let's see what this does. Cannot convert vector3 to a float. Alright, that's fine. No, we don't even need. So that's my bad again. We don't need vector 3. We can just have speed. So once we have these two here, we need Control S. And then all we need to do is go up to our update and type in move. Because move, see, we've nested things now. We have our look script, but that doesn't really matter because in move we call look. So we don't even need to call it up here because it's going to call move, and move is going to go if. All right, does look give us back null? Yes. All right, sweet. We're not going to do anything. Does look give us back null? No. Then we're going to do this. We're going to go through everything here, and then we're going to ask that again, and again, and again, and again, and again. Right? And if look is ever null, it's just not going to do anything. So once we have this, we can go ahead and save. We can go into our game. We could take our enemy AI. We can put it onto our enemy. We'll check out. All right, cool. Here, let me finish up what we got here, and then I will help you out at the end of class, okay? Because we're almost done, and then I'll stop the recording and get you all fixed up there, Mahindra. Yes, I know. All right, cool. And that's McAfee. I don't care about McAfee. Sorry. That's that. That's not what I'm trying to do. I'm just clicking all over the place today. Anyway, we've taken our enemy AI and we put it on our we put it onto our enemy. Now we need to change the speed and the range. So I'll set the speed to something reasonable like 2, and the range to something also reasonable like 5. We'll save it. I'm going to check the player, make sure, yep, player is tagged as player. And when you have those two there in your enemy, it should wow, it is insanely fast. But if you can't tell, it's moving at me. So let me go back to my enemy and change its speed to be much slower. What I'm going to do, I'm going to go in our code and multiply my speed by time dot delta time. It's a good trick if anything ever moves way too fast and you don't feel like fixing it. What that does is it effectively multiplies it by 0.02. So now you'll see if I get close enough, it's going to immediately look at me and start moving towards me, right? This is a good, like, zombie script or thing of the nature. As long as I stay in range, it's going to very fluidly follow me. And then if I move out, I'm perfectly fine. Now, the issues and the critiques of this style of AI are relevant and fair. Because if I sit here with this cube in the way, it'll get caught. But for our purposes, this is going to work. Right. This is what you need by. This is what you should have at the end of class. Tomorrow we'll talk about having this enemy now shoot at the player, and maybe you shooting back, depending on how long that takes. All right. Hope you enjoyed class today. Goodbye.